Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 10, File Upload Security. Alice, legal tech is fundamentally a document management business. Lawyers upload files constantly. Contracts, pleadings, exhibits, evidence packages. So what's the threat here?
Every uploaded file is an opaque blob of bytes crossing a trust boundary into your system. The file claims to be a PDF. The content type header says application PDF. A MIME type, multi-purpose internet mail extensions type, is just a label declaring the file's format. The extension says .pdf. But none of that is verified until you examine the actual bytes. A file is whatever its content makes it, not whatever the uploader claims it is.
Right. So the extension and MIME type are essentially just labels the attacker controls.
Exactly. An attacker can rename a PHP web shell to evidence.pdf, set the content type to application PDF, and upload it. If your server stores it in a web-accessible directory and serves it based on extension alone, they navigate to the URL and the web server executes it as PHP. They now have remote code execution, the ability to run arbitrary commands on your server as if they were sitting at the keyboard.
That sounds almost too simple. Surely modern applications don't make that mistake.
The basic version is less common now, but the attack has evolved. Polyglot files that are simultaneously valid as multiple types. A file that has valid JPEG magic bytes at the start passes image validation, but also contains executable JavaScript. Served without the right headers, the browser may interpret it as a script instead of an image. Port Swigger demonstrated bypassing content security policy. The browser enforced rules about what scripts can run, which we'll cover in depth in episode 12, using polyglot JPEGs.
Right. And then there are archive bonds.
Zip bombs, a 42 kilobyte zip file that expands to 4.5 petabytes across nested layers. If your legal SaaS automatically extracts uploaded archives, which is common for bulk evidence ingestion, that expansion exhausts disk space, memory, or both. Your entire platform goes down. Denial of service from a single 42 kbps upload.
Okay, so what's the validation approach? You said magic bytes.
Magic bytes are the first line of defense. Every file format has a characteristic byte sequence at the beginning. PDF starts with %PDF. JPEG starts with FFD8FF. PNG has an 8-byte signature. DOCX files are actually zip archives, so they start with PKI03-04. You read the first few bytes and confirm they match the claimed format. The Python magic library wraps libmagic, which identifies files by content rather than extension.
But you said polyglots have valid magic bytes for their cover formats, so magic bytes alone aren't enough.
Correct. Magic bytes confirm format identity, but not safety. A polyglot JPEG has valid JPEG magic bytes. A PDF with embedded JavaScript has valid PDF magic bytes. You need deeper structural validation. For images, decode and re-encode. If you receive an image, run it through your image library, decode it to raw pixels, then encode it as a new JPEG or PNG. Any embedded payloads in the original file's metadata or trailing data are destroyed in the re-encoding. What you store is a clean image you generated, not the attacker's file.
That makes sense. What about documents? You can't re-encode a contract PDF without potentially losing content.
For PDFs, you sanitize. Strip JavaScript. Legal documents have no legitimate need for executable code. Strip launch actions, embedded files, form submission URLs. QPDF can linearize and clean PDFs. For DOCX files, strip VBA macros unconditionally. Reject macro-enabled formats like .sem and .xlsm at the allow list level. Parse the internal XML with external entities disabled to prevent XXE. XML external entity. Attacks, where the parser is tricked into loading files or resources it shouldn't. Remove external template references that could phone home or steal NTLN hashes.
Yeah, that's a lot of processing. How do you do it safely? What if the parsing library itself has vulnerabilities?
Which you will. ImageMagick had ImageTragic in 2016, remote code execution via crafted images. GhostScript had a remote code execution flaw in 2023 via PDF processing. LibTF has had buffer overflows. The answer is sandboxed processing. Every uploaded file goes through a pipeline. Quarantine storage first. The file sits where it can't be accessed via URL. Then a worker process in an isolated container. No network access, limited file system, minimal permissions, performs all validation and transformation. If the processing triggers a vulnerability, the attacker gets control of an empty sandbox with no access to your application or data.
Containers specifically, or VMs.
Either works. The principle is isolation. A container with no network namespace. A read-only file system except for its working directory, dropped capabilities, and SecComp filtering is sufficient for most threat models. If you're processing files from nation-state adversaries, which some legal firms do, VM isolation via Firecracker or pvzr provides stronger boundaries.
Once a file passes validation, how do you store it?
3 rules. First, random file names. Generate a UUID, a universally unique identifier, a long random string, or content hash. Never use the user-supplied file name in your file system path. User-supplied file names can contain path traversal sequences, .. that overwrite system files. Second, store outside the web root. Files should never be directly accessible via URL. Serve them through a controlled endpoint that checks authorization before each retrieval. Third, serve from a different origin. If your app lives at legalapp.com, serve files from files. Legalapp.com. Same origin policy prevents any script in a search file from accessing your application's cookies or DOM.
What about the response headers when serving files?
Critical. Content disclosed attachment forces the browser to download rather than render inline. So even if the file contains HTML or scripts, it won't execute in the browser context. X content type options. No sniff prevents the browser from guessing a file type different from the content type you set. And always set an explicit, correct content type based on your server-side detection, not the stored original claim.
Let's talk about legal specific formats. PDFs are the obvious one.
PDFs are probably the most complex file format in common use. The specification, ISO 3020000, supports JavaScript execution, launching external applications, embedded files, form submission to external URLs, and encrypted payloads. A PDF from opposing counsel could track when and where it was opened via an external reference, a digital tracking pixel. It could exploit a reader vulnerability for code execution. It could contain a phishing overlay that mimics your firm's login page.
Right, and DOCX files.
DOCX is a zip archive containing XML files. VBA macros. Visual Basic for applications, small programs embedded inside documents, are the classic vector, arbitrary code execution if the user enables macros. But there are subtler attacks. External template references. The document silently loads a template from a remote server when opened, sending the user's NTLN hash, a Windows authentication credential, in the authentication handshake. DDE fields, dynamic data exchange, can execute system commands without macros. Even the XML itself can contain XXE payloads if your parser resolves external entities.
Right, and TIFF, those are common in legal scanning workflows.
Multi-page TIFFs are standard output from document scanners used in legal firms. The libtiff library has had recurring buffer overflow vulnerabilities, where malformed data overruns a program's memory boundaries, letting attackers hijack execution. Malformed TIFF headers crash the parser in exploitable ways. Process them in your sandbox, keep the library updated, and consider re-encoding to PNG for storage if you don't need the multi-page container format.
So the complete picture: allow list permitted extensions, validate magic bytes, scan for malware, process in an isolated sandbox, strip dangerous elements format by format, store with random names outside the web root, serve from a separate origin with restrictive headers, and check authorization on every retrieval. Ugh.
Every step matters. Skip the sandbox and a parser vulnerability gives the attacker your server. Skip the separate origin and a polyglot gives them XSS. Skip the authorization check on retrieval and any authenticated user can download any document. File upload security is the entire pipeline, not any single check.
Next episode, webhook security and SSRF. What happens when your server makes outbound requests on behalf of external services and attackers exploit that trust relationship?
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.